So now let's switch gears and let's talk about some new malware. So yesterday I was tagged in a tweet, and the tweet was from John Lambert. John Lambert is I'm not sure the exact role, but basically he works at MSRC, Microsoft Security Response Center, and they do a lot of cool malware analysis. And in his tweet, it basically says, hey, look, there is a document, Word document with macros in it, and it doesn't work on Windows. Why? Because it's targeting Mac Office. And he tagged me in that, which was nice, because I've written about this a little bit before. And then he provided a link to the file on VirusTotal. So what we're going to do now is we're going to walk through analyzing this document. And this is kind of cool. This is probably some of my favorite things to do. And this is analyzing files that potentially are malicious to try to pull out the logic and ultimately understand what they're trying to do. And the first thing to note is, of the 59 engines on VirusTotal, only 5 of them currently flag this. That's, in my opinion, sad. So we can see, for example, the engine on VirusTotal that belongs to Microsoft doesn't even flag that. Now, I will caveat, and this is important to note, that the engines that are running on VirusTotal don't always match what's running on end users' systems. So a lot of times people say, oh, look, this file isn't flagged on VirusTotal, and that may be true, but on an end user system, that's not the case. So there's actually a kind of a statement on here. It says this may differ from the company's particular product. So again, always good to caveat that. Still, the fact that the majority of these antivirus products aren't flagging it, even on VirusTotal, is sad. However, there are a few that are. ClamAV, Endgame, SentinelOne, no idea what this is, and Adaware. Oh no, it says it's clean. Flagged. So these 5 say it's malicious, Endgame with high confidence. So this is likely a malicious file. So what we can do is we can hop over to a VM, because when we do malware analysis, it's always good to do it in a VM. Oh man, what's the password for this? Okay, we're in. So the first thing we're going to do is we're going to download this file. Okay, file's downloaded. So the first thing I always like to do is run the file command to see what kind of file this is. And that's important to do because, especially in macOS, a lot of the attacks require user interaction. So what attackers will do is they will, for example, attach a malicious application to an email, and they'll use a PDF icon and say it's a PDF document. And we'll try to get users to click on it. If user is tricked into clicking on it because they think it's a PDF document, and then they click allow on the subsequent alerts, they will have infected themselves. But when you download it, you're like, well, this looks like a PDF document. But is it a PDF document? Is it an executable? What is it? So the file command is a built-in utility, and it will tell you what type of file you've downloaded. Okay, so we just downloaded the file. And we can see it's a Microsoft Word document from 2007. Or Word 2007. So this is cool. I mean, this is what John tweeted. He said, hey, this is a malicious Word document. So we've basically just confirmed that we're working with a Word document. So now how do we analyze this Word document? Because a few of these AV products say it's malicious. We want to confirm if it's malicious or not. We also want to figure out if it is malicious, what is it doing? Does it have a persistent implant? Is it going to download something else? So now let's talk about how to analyze a Word document that we think is malicious. And I will caveat that although I really like doing malware analysis, my techniques are kind of ad hoc. Like I don't have a lot of, dedicated procedures. I just kind of hack away. So, if you're doing a malware analysis on a more broad scale, it's probably better to have some automated steps. But I like the more manual steps because I think it's more hands-on and really illustrates what's going on. So John mentioned in his tweet that it is a malicious Word document that uses macros. And this is very common. Macros basically provide a way for code to automatically run when a document is opened. So what we want to do is we want to look for those macros and extract the macro code to see if it's malicious and understand what it's doing. So the first thing you need to know about Word documents, since I think 2007 forward, is they're actually zip archives. So what we can do is we can simply unzip this file. So if we unzip the file, actually let's cd into downloads. Unzip 44. Cool. We can see that, as I mentioned, even though this is a Word document, it's actually an archive, which means it can be unzipped. So we can see now that this has inflated, in other words, unzipped into a variety of different XML files. Now, macros will be in the vbproject.bin file. So if there's any macros in a document, once you've extracted it, they will be in this document. So let's go into there. And let's first look at what type of file that vbproject.bin is. Okay, it's a composite document file v2. I don't know what that is, but if we take a look at it, we can use the less command, vbproject.bin. We can see it's a binary file. So this doesn't really help us. We can see that there's some references to macros. There's a bunch of other stuff. But again, this is essentially not readable to us. It's in some proprietary Microsoft format. Luckily, we can use the SIG tool from clamav to extract macros from these documents. So this is a really helpful utility. You can, I think I installed clamav already. Yeah, so you can install clamav on a Mac via brew install clamav. And again, this, as I mentioned, will install a tool called SIG tool. So what we can do is we can execute the SIG tool utility, and if we pass it the --VBA flag and the path to the file that has the macros, which is this VB file, vbproject.bin, it will decode, decrypt, decompress, whatever format the file, that bin file is, it will extract the macros. So, you guys ready to see some macros? Boom, look at that. So, awesome. Make this a little bigger. So let's see, just kind of start going through this. First thing we have here is, or one of the things we have here that sticks out is document open. Document open is a macro API, and this will be automatically invoked if the user clicks allow macros when the document is opened. So a lot of malware that uses macros will have their logic in the document open function because this will be executed automatically when the document is opened. So it's kind of like a main function in a binary. So we can start looking at some of the code to see what this does. So the first thing we notice is there's something called payload. Again, this is the attacker's code. So that's, again, a very clear indication that something funny is going on, malicious rather. We can see that there is some base 64 encoded data, which again, there's no legit reason why this would be. We can then see there's a path to launch agents, and it's going to persist something called com.xpcsec.plist. And then there's an embedded plist. This plist is going to be installed, or likely is going to be installed, as a launch agent. Launch agents are basically something you can create legitimately, and what they are is a way to persist. And what persistence means is it's a way to install something so that every time the system is rebooted and the user logs in, this will be automatically executed. And this is something basically all malware seeks to achieve, persistence. Because if malware didn't persist and you rebooted your system, the malware would have just lost the ability to execute, right? You would have just disinfected yourself. So again, essentially all Mac malware goes to persist. And the most common way is to persist as a launch agent. So again, if we look at this, we can see a string to the launch agent directory, and we can see an embedded plist. The plist, again, is basically how you install yourself as a launch agent. So we can see, for example, the program arguments. This tells the operating system what to execute. We can see that there's Python, and then -c, and then payload. So this basically means every time the user logs in, via Python, they're going to execute whatever this chunk of code decodes to. And since run at load is set to true, this tells the operating system to automatically execute this. So this is like a persistence key. And if you're familiar with Windows, this is kind of like an auto runs key. So at this point, we could be 100% certain this is malicious code. We still don't know what it's going to do. We can say, okay, it's probably going to persist using this launch agent name, this property list, and here's the property list, but we don't know what this code is. However, since it's base64 encoded, we can simply grab this and debase64 encode it. So let's do that right now. So there's probably faster ways to do this. As I mentioned, I have my techniques that seem to work. So we're going to copy and paste each line of code. Actually, let's make this a come on. So we're just grabbing the payload. Again, this payload is base64 encoded. What we're going to try to do is we're going to try to decode it so we can see what it is. So we grab this last line of code, including these equal marks. This is padding for base64. Okay, so let's copy this. Now we have just one line. Here, obviously, they split it over multiple lines, which will break the decoding if we try to manually decode it. Now, for me, the easiest way to decode it is just using Python. So let's hop in here, open a Python interpreter, import base64. This is the base64 library. Let's create a variable called payload that has the base64 encoded content that we extracted from the macro in the malicious Word document. Now what we're going to do is we're going to base64 decode this. So we say base64.b64 decode, I think is the format. And then we pass it the parameter and 3, 2, 1, boom. Look at this. Python, cool. Socket code, we have an IP address. Dope, exciting. So what we have got so far is we had a Word document with macros. We've determined that the macros would be automatically executed when the document was open, assuming it was opened in Office and the user enabled macros. This payload would get decoded. We didn't know what this payload was, but using the base64 decoding library in Python, we basically just decoded that. So this is kind of awesome. Yes, this is sweet. I get really excited about this stuff. So let's go back and pretty this Python up because it's still a little ugly, or just format it better so that we can read it. We could probably do this online, but yeah, whatever. Okay, so bear with me. So the first thing they do is they import a bunch of needed libraries, the socket library, the structure library, and the time library. Then they have a for loop that says for x in range of 10. So they're basically going to try this 10 times. And then they have a new line and a tab. Hope this isn't too painful to watch. They then have a try. So what this is going to do is in an exception handler, it's going to try to create a streaming socket. Then it's going to connect or attempt to connect. And this is why they have this in a try except, because if the network is disconnected or this command and control server is offline, this would throw an exception. So they wrote good Python to wrap this in an exception handler. And then if that's successful, they're going to break, which is going to exit the loop, because obviously they don't want to try this to do this 10 times if it succeeds. They then have the accept block. The accept block, again, this is Python code. This will catch any exceptions. So if it can't, for example, talk to that IP address because perhaps the user's system is offline for a minute, they will sleep for 5 seconds. And then they will go back and execute the next iteration. So basically, they're going to try 10 times to connect to 109, 202, 107, 20 on port 9622. What they're then going to do is, let's try not to screw this up. Let's format this code while less than, and probably could have done this online. I'm very manual. For me, it's like, I don't know, more hands-on experience. Okay, so here's our Python code. So once they've connected to this socket, they will call receive to receive, I think, four bytes at a time. And they will put that into L. Oh, so this is probably going to receive the length of the data. So we don't know how their custom command and control server is set up, but looking at this, we can see they call receive to get 4 bytes, and then they pass and save that into L. Then they pass that L into another call, another receive call. And again, receive is going to receive data from that remote server. And it takes the number of bytes you want to receive. So what they're doing is, as I mentioned, first receiving the length of the data in the first call to receive, and that length will be 4 bytes long. And then they call receive again with that cumulative length to receive the rest of the data. Then in a while loop, they basically call receive, trying to get, I guess, the rest of the data. Oh, and this exec should be outside of it. And then they will basically execute whatever they downloaded. So now we know that this Word document is going to basically execute this base64 encoded Python. Well, actually, it's going to persist it as a launch agent. And then every time the launch agent runs, it will try to connect out to this IP address and download this. So this basically means that this Word document, you can think of it as a first stage downloader. And this is very common in malware, right? They're not going to probably put the whole implant, the whole backdoor into their Word document for size reasons and security reasons. It's way simpler to write a small, compact downloader that simply beacons to a malicious attacker-controlled command and control server and then download that instead. This also allows the attacker to update the implant, because this launch agent will execute whatever the attacker gives us. So I have no idea if this IP address is up. We can ping it to see if it is. Probably should do this through a VPN, so the the attacker or whoever is controlling the server, doesn't see my IP address. But I like to live on the edge. So it looks like it's up. So should we try to run the downloader and see what it gives us? I think we should. Okay. So let's modify this a little bit. We can just execute these 3 lines. Let's comment out the Python. I think it's with 3. Yep. We don't want to exec what it's downloaded because we don't know what it's downloading, even though it's in a VM. So let's just connect to this server and then maybe execute this. So this is going to be putting it in the D variable, and then we can just do print D. No, we don't capitalize that. Okay, so let's save this as malware, no, payload.py. Okay, so make sure there's no mistakes in this Python code. I guess we'll just run it. First thing we do is make it executable. Okay, let's try run this and see what happens. Ha, sweet. So the server is live, and it gave us back all this lovely Python. Okay, let me just download this again and save it to a file. Oh, this is awesome. This is called the stage2.py. So it looked like it was Python code. Cool. So now let's see what we downloaded. This is awesome. A lot of times attackers take their command and control servers offline or, for whatever reason. But this looks like it's live. So we were able to extract the embedded Python, execute it, and see what the second stage of that is. Again, this is very rare. So we can see there's more Python. This is not too surprising given the fact that the attacker has written his first stage downloader in Python. So we can see they import a bunch of required libraries. We can see OS, platform, socket, subprocess. So this looks like this probably does a lot of stuff. We can see they import C types. We can see that they try to import WinDLL. So maybe that's first to check to see if it's running on Mac. They then try to import a bunch of URL stuff. I'm just going to kind of skim through this because this looks like a lot of helper code. It's interesting, there's a lot of comments here. There's a payload UUID, session UUID. Oh, this looks like very well-written code. So I'm wondering if this is something open source or publicly available, because attackers usually don't write this well-commented code. Okay, generate request. There's like debug statements, again, rarely found in. Get the architecture type, platform name. Oh, so this is designed to run ARM, x64, x86. So these are usually you have helper functions at the beginning, so you can see like packet type stuff. And then, Meterpreter channel. Okay, so this might be Metasploit Meterpreter callback thing. I don't actually know what that looks like, but this would be my guess. We can Google some of this stuff in a second. So let's hop over to Google and just Google some of these strings. Because again, given like the quality of this code, it has comments and debug statements. Again, this is not something that's generally found in like custom written malicious code. So meterpreter.py. So yeah, this is probably Metasploit's. Yeah, okay, this is exactly what it is. So we can see has, that C-type check, that proxy handler, blah, 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 blah. So this is exactly what was downloaded. So this, again, is fairly common. Lazy attackers or attackers that are using attacks like Word documents and using macros. Like, that's not the most, let's say, advanced capability, right? The NSA is likely not sending Word documents with macros around, I assume. It's a very like script kiddie type approach. Come here. Havana's going to help us out with our malware analysis. So what attackers will often do is these kind of low-tech attacks is they will simply craft a malicious Word document, use macros, and then just grab something like Meterpreter off the shelf. And since it's embedded in the second stage downloader, it's likely not going to be detected in the Word document because it's actually not in the Word document. So they'll write, for example, a custom downloader so that AV products won't detect that, but then use like a known backdoor. And this is just because a lot of them aren't, probably capable of writing advanced backdoors. Cool, so that wraps this part of the live stream up. Just to reiterate, we started with this malicious Word document. We downloaded the Word document. We unzipped the Word document, because again, Word documents are archives. And once we did that, we used the SIG tool from ClamAV, which you can install via Homebrew. And you can point it at that VB bin file, and it will very nicely pull out the embedded macros, which is really cool. So very quickly, you can see exactly what's going on. I don't have Office 2007 installed on my system, so I don't know how to execute this per se. But if we did execute this, it would likely also persist this launch agent. And again, what it's going to persist, is that code, which is going to try to connect to the command and control server. This means every time the user logs in, it will try to connect to that server and download whatever is there. We got really lucky because that command and control server was still active. So when we executed the request, the attacker gave us what the second stage downloader was. And as we illustrated, it is Meterpreter shell. Meterpreter obviously belongs to Metasploit, and it basically, my understanding is it provides you an interactive reverse shell. So that's really cool, because what that means is the attacker can basically now fully command and control any infected systems persistently. So it's unsure what they would do at this stage because he's using Meterpreter. He or she could be doing anything. So, installing a crypto miner, installing a keylogger, exfiltrating files, installing other malware, adware, et cetera, et cetera. But at this point, the system is completely owned. So if someone were to be infected like this, the way to disinfect themselves, yes, would be to delete this launch agent, but it's probably also good for them to restore their system and change all their passwords, because you never, via Meterpreter, the attacker could have really installed anything. So I always tell users like, hey, yeah, you can delete the malware, but did they install 5 other backdoors? Did they install a keylogger? Did they steal all your passwords? So really, it's good to completely reinstall macOS, which is very easy to do via the recovery OS, and then change your passwords just to be safe. And for God's sakes, don't open Word documents with macros. I mean, that's like 2000 and late. So that's a wrap. We've been live streaming for about an hour, so I don't want to keep chatting. I'm going to try to do this more often, though. Again, what we will normally talk about is blogs that I've written, which will cover vulnerabilities, perhaps other interesting Mac security news. We'll also then, if there's new malware that's out, for example, this one that was tweeted, I think today or yesterday by John, we'll dive in and I'll basically just walk through how I analyze these samples. This sample wasn't particularly sophisticated, but we did go over some good techniques to show how to extract macros from a Word document, how to base64 decode embedded stuff. And then we were lucky enough that the command and control server was still open. So before all of you leave, again, I really want to thank you for attending my first live stream. This was super fun. Make sure you all subscribe. And if you have any questions, I'll hang out for a few more minutes. So if there's any questions about the vulnerability we discussed, any questions about the malware analysis, any questions about my tools, if you want to ask Havana a question, she's happily chewing on a bone at the moment. I can interrupt her to ask that. Also want to thank GamerBot for helping me moderate that. Mad mahalos to him. Thanks, GamerBot. And also thank all of you for following me on Twitter, supporting me on Patreon. Yeah, couldn't do all this stuff without you. So again, let's hang out for a few more minutes. If there's any other questions, let me know. Thanks, Stuart. And yeah, I'm going to try to do this a weekly thing. Still figuring out the exact schedule. Oh, great question. Marriott information. Any thoughts on the breach? So this isn't something that's Mac specific, but Marriott is the latest, let's say, company that got breached. And, unfortunately, at this point, it's like basically pretty much every company I can think of off the top of my head has got breached. I mean, you had Target, Home Depot, Marriott, it's just, well. So unfortunately, kind of have to assume at this point that any information you're giving to these companies, at some point a hacker might gain access to. And this is actually a good mentality to have anyway. So the question then is, okay, do I just not sign up or use Marriott? No, it's not really practical, because again, it's essentially all these companies are going to get hacked. The most important thing you try to do is generally don't reuse passwords, because what most of these hackers are doing is, yeah, they might be trying to get your social security number and your, say, date of birth, but identity theft isn't really that common anymore. I mean, it still happens, but what they'll try to do is they'll try to use your password to access other systems or other accounts that then might be easier to extract money out of. So obviously, you shouldn't use the same email and password for Marriott as you do your bank, because what hackers will do is they'll basically grab this list of emails and passwords from Marriott, and then they will have automated tools to basically try all these other services all over the web. So they'll try to log into Target and Home Depot, and eventually a large percentage of users will have registered, say, with Target or some other company, maybe even Apple, with that same username password combination, and then the hackers will be able to, for example, get access to their Apple account. And that's a lot more powerful, because then they can do things like perhaps remotely wipe your phone, send you spam via your iDevice that can basically ask for money. They might be able to do some ransomware type stuff of your iCloud account. So again, their goal is generally to make money. So, just the best advice, other than going and living in a cave, which isn't really practical, is to really make sure that you use unique passwords. So I use a password manager. I use 1Password. LastPass is also great. And that manages all your passwords for you and will generate unique passwords for each system. So that's really great. Like I don't know what, for example, my password to well, I don't think I have a Home Depot account, but if I did, I don't even know what my Home Depot password is. Password one generated a unique one, and then when I go to log into Home Depot, it will give me that password and autofill in that. So again, if someone then hacked Home Depot or Marriott, my password and email is really essentially useless to these hackers. So excellent question. Use a password manager, and again, just assume anything that you put on the internet or give to a company will get hacked. And this is why one of the reasons Objective-C doesn't like ask for any information, because it's just like, I don't want to even collect that information because it's, difficult to protect, and it's also just liability. So hopefully Marriott, gives us all free rooms as a thank you for dealing with them, but I doubt it. So again, I'm on Twitter, Patrick Wardle. If you subscribe to Twitch, next stream, you'll be notified. I'll also put on Twitter. Excellent question. Has Password One or any similar password managers have any advantage over Safari? And that's actually a really good question, because I think the Safari one is probably a great one to use if you only use Apple products. When I started using 1Password, I think Safari keychain wasn't built in. But if you're using just Apple products, the Safari one is probably great. I believe it syncs with iCloud. I would just say really make sure to lock down your iCloud account by turning on, for example, dual factor authentication, which is a good thing to do anyways. And that's actually another recommendation, assuming that your information is going to get breached, for example, with Marriott or Home Depot or Target. Again, having dual factor authentication on all your accounts where possible, even if you do use the same password or the hackers gain access to that, again, that's not going to give them any benefit. So I think Safari one, I don't personally use it, but I assume it's good. I've heard good things about it, and I think it's free. I like 1Password. It has some extra features. It works on all devices, but again, the downside is it costs a bunch of money. So thanks, Kenny. That's a great question. If you don't use a password manager, I would start with Safari one. If it's sufficient, you're stoked. If not, maybe look at 1Password. Awesome. Well, I aimed for an hour. We hit an hour and 20 minutes. I do like to talk. Thanks again for attending the first live stream. We will try to do this maybe once a week. And subscribe. And I will post this online as well. I made a recording of this. So we will continue. That will be available online if you want to share. So thank you again, and aloha, and see you hopefully all next week.